This material deserves a video of its own, so let's do that. Let's go on back to this frequency tester for transistors. I finished the sprint layout, and this is what the board looks like. And let me show you something that I can do with this program, and I'm not sure you can do it with KiCad, but I mentioned that, let me kill off the silk screen here and just look at the board. I mentioned that I had to go back and add the thermal pads here for everything that goes to ground. Now there's a feature in Sprint that allows you to test a circuit. And what I'm going to do is I'm going to put fire up test, go to one of the thermal pads and left click on it and test it. Notice that all the ground pads flash pink. So I can look at pads, and if one is supposed to be grounded and it's not flashing, then immediately I know how to fix it. So now I've got to do something here. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's go back here. We got an input thing here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got a ground pad for the test point. It's 12. I got a ground point for the RF probe. I lost count. So anyway, gives me a way to check things out. Also, here's another thing. Let's go back to here. If I input a signal here, where does it go to first? Well, it goes to these two nodes, and it is input to these 4 resistors. So let's go back here. Let me go ahead and turn the screen on, and let's do a test, and let's go to the generator and input a signal. And we see that it goes to the 4 resistors, 100, 561K, whatever. Let's take the top branch. What happens to the signal after it passes through these 2 resistors? Well, it goes, look at what it goes to. It goes to the 2 10s, the 2 100s, and then out to calibrate. And this is something I added for the RF probe. So we go up here and look. Out of here, it goes to the 2 10s and the 50, which we made up of 2 100s, and then the cal. So that branch of the circuit is checked. Let's go to the second branch. Start here at the coming out of 56100. Here's coming out of 56100. We go to the 27, and then we'll go to the 1 microfarad. Going back here, coming out, it goes to the 27 and then to the 1 microfarad. Coming out of the microfarad, it goes to the 82 ohms and then to the 1K that goes to the base of the device under test. So here we go to 82 and the 1K, and then here, and then there's what? There's a 150. Okay. So the 150 is on the other side of the 1K. So I made a boo-boo. How do I fix that? Well, that's easy. I'll go back to edit. I'll take this path here and delete it because I want to get 150 on this other side And I can't do that because we've only got one layer. So let me get rid of this. Let me go back and do a track, and I want to go to the switch. So I'm going to go here from cow. Whoops, that's the ground. Let's go here from cow. Oops, I got the back to test. Okay, I want to go. Cow comes out all of this. Let me just start here so we don't get confused anymore. Go down here. Okay. Will that work? Yes, it will. Now, let's go and delete this. And that is supposed to go here. So I will do a track. Boing. And voila. Now let's go back to my test. And coming out of the 1 microfarad there, we go to 82, we go to the 1K and to the 150. So going back here, we go to the 82, the 1K, and the 150. Coming out of the 150 goes to the power, to 22, and then the 1 micro. So that goes to power, the 22, and the 1 micro. Let's go back to what happens to the signal coming out of the 1K. Well, it goes to the base of 222, and that's it. The emitter we don't have to worry about, do we? If you want to test it, we'll test it. It goes to test point to the 1 microfarad and then 100 ohms. And last but not least, what happens from the collector? The collector goes to 22 and then to the 1 micro. So the collector goes to the 22 and the 1 micro, and then out of the 1 micro, which is the output signal, it goes to my 50 ohms and then to the output port. So out of the 1 micro goes to 100 and 100, which is 50, and to the output port, but I also send it to the RF probe. So that checks. So it's a good thing. I always do this. I set on a circuit. When I finish it, I just immediately save everything, go away for 12 hours, come back and double check everything using this procedure. So I'm pretty sure that is set up. Something else that I can do. Let me go and do the following. Let's go and let's go to the silk screen and let me turn off the board. I do that by clicking on C2 here, and the board goes away. So this will give me my layout diagram. Let me bring the top layer, which I don't have anything, but it brings me the pads. Now what I have discovered here is that for those of you who want to do Manhattan, then here's where your pads go. except for the ground pads. So if you're doing circular pads or square, you put pads at each one of these points. There's a grid so you can measure, the size of the board. The only thing that you have to worry about is where are the grounds, and I don't need a pad there. I just solder that lead to ground, 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 ground. Figure out how to get ground there. I can put a pad there and then wire a lead chip, a component lead that I've cut loose, and just solder it from the pad to ground. Here, I can put a pad there, and instead of doing this pad, I can just do the lead from there to there. So there's a couple of shortcuts, but wherever there's a wire or a trace, then you can just connect wires if needed. So I kill two birds with one stone. I can do Manhattan, plus I can do the toner transfer. And what I'll do is, let me show you this. Let's take this diagram. Now, this program has a file that I can export the image in a JPEG format. I'll do it 300 DPI, all visible layers. I'll do it to my sprint files, and let's label this. This is ACES-001. This is first image.jpg. Save it. Now, if I go to no, I got it right. I've got ACES-001, so I can look at it. Gthumb, ACES.jpg, and voila, there's the image. And that's a JPEG, so I will save it to the home page adjacent to this video where the link points to it. And I'll do this for all layers, for the parts layout, and then the PDF to be printed onto photo gloss slick paper for transfer to the printed circuit board. Let's see what I'm doing on my time, because I just got so much to cover. 13 minutes. That's it. I'm going to stop right here. I'm going to go and print this off and then do a video on how to transfer to the PCB. Thank you for your time. Hope this helps us get further along. Again, I'd appreciate some likes, and thank you, and come back again.